Okay, we're starting with the net force is equal to the magnetic plus the electric. What's the magnetic force? Just gave it to you.
QVD sine theta.
QVD sine theta. Okay, that's magnetic. What would be the electrical? Let's see how well you remember. F equals what?
K
You could. E over Q.
Q over E.
QE. Okay, so we have the magnetic and the electrical forces there. Okay, and what they do is, it was Lorentz that discovered this, so they actually give it the name F Lorentz for the Lorentz force.
These named it.
They factor out the Q, and you get VB sine theta plus E, the electric field. So this is known as the Lorentz force. Okay, the Lorentz force. Lorentz. Okay, and we're looking at crossed electric and magnetic fields. Okay. You say, well, who the hell cares about this? Well, Lorentz did.
Everyone named it the Lorentz
This
force.
is also the basis for tube television, because electric and magnetic fields. If you realized it or not, how those TVs work, you notice how I was bending that beam? If you know how a TV works, not how a TV works, inside a TV there's we'll talk about a black and white TV to begin with, there's an electron beam, okay? And what it does is called electron gun, and what happens is that the magnets in there take that beam and sweep it across, line by line. It sweeps it, and it creates the image. When it gets to the bottom, it sweeps it again. Okay? You look at a flat screen TV right now, which is 720p. Do you actually understand what that means?
Pixels per inch.
Well, pixels, not exactly. Actually, that term 720p is a misnomer. They borrowed it from standard 2 television. It meant 720 lines being traced out on the screen. Well, there are no lines traced out in a flat screen TV. They're pixels. Okay? So when they say, oh, we have 480, which is a cheaper thing, that meant 480 lines. Okay? That thing wasn't even close to 480 lines. That's why the resolution on that is crap. Okay? Because a thing couldn't sweep 480 lines. No magnet's going to sweep that much. It's doing a pretty damn good job. And when I was a kid, back in the old days, okay, there used to be knobs on this thing that used to be able to turn, and you could actually take the image and flip it. Actually make the image come up halfway. You could put the picture halfway up on the screen. You can believe this? Okay? And if you looked real close, you actually saw the beam going across, tracing the image line by line. You could actually see it. Okay? Kind of cool, you know, for it. But that's what that comes when they say 720p, 480p. So when they use those terms, it's actually a carryover. And what do they mean by 1080i? Now that's bull also. Because 1080i, interlaced. Okay, you do the term. 1080, but is that term making sense, Jason? For a flat screen, interlaced. Now, anybody have an idea? Interlaced. So where's that term coming from? From that TV. You had the beam going like this. What do you think it meant interlaced?
Another beam.
Another beam was going in between the other beam to interlace the image, so you had less flicker. But on this type of thing, it has no meaning whatsoever. It's a marketing point. Oh, 1080i versus 1080p. Now they're just charging you $100 more. It really has no meaning whatsoever. 1080i versus 1080p. All marketing.
Kind of sounds cooler though.
Isn't it? These are all the fonts of knowledge I'm giving you. So there you go. 1080i.
Go buy the other one.
Huh?
So buy the cheap one.
Buy the cheap one. Actually, you're better off buying it cheaper. Unless you have a lot of people. I just installed a friend of mine in his house a high-def TV for his bedroom on a wall-mounted, and he gets the little Comcast converter box.
Okay.
Was that a waste of money?
Limited by the
Yeah. The converter is what? The little converter box if you have Comcast is what?
non-HD.
Yeah, it's not HD, it's 40p. Lucky if you get 720 out of the damn thing. Okay, so you buy this nice high definition television and the image you're gonna get is never gonna be that.
That's it.
Yeah,
Did you tell
yeah, after, well, he already bought it, it's not, I already had it drilled into the wall. I said, oh, by the way, you got a crappy box.
them? You should tell them.
No, he went out and got the better box.
Okay, good, that's what I'm saying.
It costs so much though for the.
The bigger box, yeah.
But I mean, if you bought the TV.
The bigger box is
there's no
$10 a
point.
month, and the little box is $2 and change a month, so.
Yeah, because I have a nice TV, but my parents don't buy me the big box.
Oh. Let's take a collection off the chair.
Oh, Jared, I'll take your TV off.
No, it's good for Xbox.
Part of the penny day money every week.
The penny day, we're gonna start a penny day.
It's still good for Netflix.
It is,
It's still $7.20 or whatever.
Every Thursday, I'm like, waiting for Jared's new-
No, it's sad. It's sad.
Nice little bit, though, see if I get it done today. If you want to calculate the work being done here, work, how would you calculate the work? Force times distance.
You what? FD.
So if I do that,
That's why he's always like 10 hours more.
would I have to do something here?
Takes it.
Yes, Mr. McLean. Yes, you would have to do something there.
They used to do like you got
We're
an
just
ice
so
cream party
excited
or
about
whatever.
physics.
Like they would bring an
Okay.
ice cream or whatever
So,
for the class.
I
They
took the
run
sine beta out
I
because
don't
they're
think so,
costing.
because I don't think they make
So I
enough
put
money.
the X in there, we have QEX and
Just every
QEXB.
month they give the
Okay.
$40 they bring to
Stop.
that charity.
So, okay.
He sounds like Mickey Mouse.
I'll think more Elmo.
Oh, so this is the work done by the magnetic field.
Okay.
That is definitely Mickey Mouse.
Are we no longer doing sine theta?
No, because they're cross fields. Okay.
We did sine theta and the force of the cross fields.
Yes. I'll write the note. Undeflected. Assuming it's undeflected here, so it's at 90 degrees to each other. It's undeflected. So we have work done by magnetic field, work done by electric field. Okay. Which one of those equals 0 and why? Ah. What are your thinking caps? Which one equals 0 and why? Should the work done by the electrical field or work done by the magnetic field?
Magnetic.
Why? Huh?
I would say it depends which direction it's going.
No.
If it's going parallel to the magnetic field, then the magnetic field's not doing any work.
The electric field equals 0 because it's the magnetics union.
No. This is 0, why?
Sine is 0. Because the magnetic force is like into the board and.
The work is cosine on the magnetic field side.
The magnetic force is into the board.
The work is out.
And we're not moving into the board?
Okay.
Oh, so
And
you're not.
if we're moving that way, what's the problem?
It's not there.
Oh, it's not changing
It's
the
not
velocity
changing.
that way.
What's your direction that you're moving? Is V the same direction as S? Is your displacement the same direction as your velocity? No.
It should be.
Okay, they're perpendicular to each other. They're usually perpendicular to each other because they're a cross product. What do you have? If they're mutually perpendicular to each other and it's a cross, 0. Okay, so work done by the magnetic field, work done by the electric field. The only thing this is going to change about the particle is it's what? No. What's it going to
Acceleration.
change? What's this going to change? Is anything going to change? Are you in the sound of my voice? What is going to change here?
I'm still trying to figure out what you mean by undeflected.
Yeah, well, we're balancing the fields.
What does that mean?
They're equal.
And in the same direction?
The opposite direction.
They're mutually perpendicular.
Okay. So is the electric field going the direction of velocity or also perpendicular to that?
Yeah.
Pick one. I'm trying to figure out what's going on here. You're talking about two fields, you've only drawn one.
Right.
So it's difficult to figure out what's going on without the presence of the other field.
I don't want to give you the present of the other field yet.
got like 2 minutes
Uh,
left. Like, about time.
Other
About
field
done.
perpendicular to that field?
Do you agree with, yes.
Okay.
No, I honestly don't agree with that because I don't understand what's going on.
The field is perpendicular, so the field is going in the direction.
Why is the field perpendicular? We just arbitrarily decided
It's
this?
Because going in the
undeflected.
direction of the velocity.
It's undeflected. It's
It's
undeflected.
So we're purposefully picking a
God, it's so
velocity
slow.
such that it's perpendicular to the magnetic field.
Yes. Yes. Like, boom, it will become as clear as mud in a moment.
Alright.
Okay.
But the work done by the magnetic field is not always zero.
No, no. In this particular set.
So don't box this.
Don't box the zero part. Just the.
What does the electric field do?
Where?
I know. What does it impact?
The particle. It
What
changes its
aspect
velocity.
of it? Thank you. It impacts its velocity.
Acceleration?
What, the electric field?
So it's affecting its velocity. If the electric field is constant, what could you say about the velocity?
Constant.
It's the ex-
So, if E is constant, we're going to assume it is. If E is constant, then V is constant.
Wouldn't the acceleration be constant?
Yeah, exactly.
Not velocity?
Not velocity.
Yeah, what
It's a force.
Yes,
Acceleration.
yes, wait. Wait for the conclusion, Jason.
Imbeciles.
E is constant, V is constant. Then what does the magnetic field change?
Acceleration.
No.
Nothing.
Nothing.
Zero.
Yes, it's changing something.
No, it's
Oh,
changing.
wait.
It's zero. It's doing no work.
Distance.
But it can still, even though it's not
Charge.
doing work, it
The
can still
electric
change
field.
something.
Velocity,
Change
acceleration,
field.
distance, charge, magnetic field.
It changes the direction.
Yeah, I didn't get there yet.
That's why I did this demonstration. I was able to change the direction of that beam without changing its speed.
But
You
you are
notice-
changing its
Ah!
velocity. Velocity is a vector. You change the velocity.
Yes, because I changed its
Oh.
direction, I changed
Is that
its
why it
velocity.
became greener when you changed the electric field? Yeah.
What is this particle gonna do?
Do
Look at
it.
this.
I don't
What's it
know.
gonna do?
Depends on the charge.
What's it gonna do?
Twist. Right hand around.
What motion is it gonna create?
Curly Q.
Well, it
gonna
could.
semicircle.
I'm giving
A pig's
it's
tail.
limited at 90 degrees.
Semicircle.
A circle.
A circle, a semicircle. It's gonna do this. It's gonna go around like
You wonder
this.
how you do that?
Like that.
Yeah, it's gonna go around a circle. It's actually gonna go around a circle. Am I out of time?
Yes.
Where do you think I'm going with this? It's going around a circle.
I have no freaking clue. I feel like this whole conversation
I
went
got
in
it, so
circles.
then you keep going, something equals something, K, R,